Hello, everyone. It's the top of the hour, and this is Greg Stumpf of the Meteorological Development Lab stationed out here in Norman, Oklahoma, and would like to welcome everybody to the September version of the Virtual Laboratory Project and Community Owners Meeting. We last met about 2 months ago, and we're on rough 2 month schedule. Our next meeting will be in November, at the end of November. Um, We've got kind of a short agenda today, but it may be enough to fill out at least an hour's worth of time. You should be able to see my agenda on the screen right there now, and I'm going to go ahead and unmute our illustrious VLab leader, Steve Smith, and he's going to start off with an introduction. Go ahead, Steve, you're unmuted.
Thanks, Greg. Well, welcome everyone. Just, to remind that we hold these meetings for you, our special customers in the VLab, the project and community owners, because you're the ones really engaging with VLab in order to try to carry out whatever it is you're trying to do in a better fashion, in a virtual fashion, a more, extensible ways to interact with your customers or your collaborators or your project developers, that sort of thing. So throughout this meeting, I want you to remember that, this is for you. So if you have a question or you want to take us off a tangent onto a different tangent to address a specific concern you have, please do so. We really want to make this work for you and be of value to you. So you're the reason we're holding these things. Before I hand it over, I think there's just a lot of stuff going on in NOAA that the VLab is supporting. We continue to grow in our user base, tapping into more and more important projects throughout the agency. We've been investing a lot of time recently in supporting the NCEP's Environmental Modeling Center and its efforts to migrate its extensive suite of modeling codes into Git repos within the VLab so that they can move forward with some of their larger projects that involve external partners and that sort of thing. So that is a very large effort and involves almost every person, you could say, in EMC to make it happen. So that is bringing a whole new set of users into the VLab world that will be active and engaged on a daily basis. I mean, we were reflecting not long ago that, a few years ago, there were some quiet times in VLab when there were only a few people logged in or maybe no one. And that no longer is the case. I mean, any given time you log in, there's 30 or up of concurrent users just on the LifeRay side, and probably about the same number in working in Redmine and doing stuff. And so there really is no downtime. The sun never sets on the VLab, I guess, is one way to look at it. The big new thing we're going to touch on a little bit coming in the not too distant future is our move and upgrade to LifeRay's digital experience platform. This is a new version of LifeRay that we have recently acquired. It's got a lot of new functionality. It appears to be an attempt by LifeRay to sort of move away from their portal legacy kind of approach to its users to something a bit more robust and extensive. Ken will get to some of those details, and there'll be a lot more to come in the future as we get closer and closer to rolling that out. It looks like it's going to be a big lift for VLab. It's going to provide a lot of new functionality and modularity so that we can better support you all. But there probably is going to be some changes that will affect you as much as we'd like to make it transparent. So we'll make sure to make that you're well informed and kept abreast of all those developments. And so attending these meetings is one way to get the latest information, but we'll provide multiple ways for that. So with that, Greg, I'll hand it back to you.
Okay, thank you very much, Steve. So without further ado, let's go ahead and listen to Ken Sparrow, who's going to talk about what's new in the VLab in the last 2 months. Go ahead, Ken, you're unmuted.
Okay, great. So if I can share my display real quickly, then I will, okay. Okay, are you guys seeing it or not?
Not seeing it yet.
Okay, give me a sec. Okay, well, oh, there we go. Okay,
Okay, we see it now.
so now you should be seeing it. So the first thing is pretty straightforward to demonstrate, and that is the fact that we are actually have implemented single sign-on within Garrett. That was the third of the 4 applications. We had already done it with VLCS and then with Redmine, and this last month or so, maybe a little bit before that, we implemented it within Garrett. So when you sign out, if you are signed in to Google, your NOAA Google, then you can just click on the sign in. It will then allow you to click on the Google link, and that will then take you right in. If you have multiple profiles, like work and non-work accounts or multiple work accounts, you would select the NOAA one. It will not work with non-NOAA accounts. And for those that are coming in, if you happen to be doing a review or need to be interacting with Garrett and you're on the AWIPS network, you can still sign in using your normal credentials. So that's something new, and hopefully that will ease. I know I personally appreciate it. So that's a nice new feature. Another thing that we've done in support of the EMC, which isn't on the agenda, but it is related to this, is that we now support external accounts for external partners within Garrett. This was important for EMC and NCEP because many of their projects have a lot of collaboration with external users, and they wanted to be able to allow external users to be able to contribute to their projects by doing pushes up for review. So that's an option now, and be aware of that as a owner of your project. That's something that can be requested. So that's a sign on, and the other. Steve did a good job of kind of giving you an overview of LifeRay DXP. We're working through the technical issues, migrating. It's a good and bad thing. We've spent a lot of time customizing LifeRay for VLCS, and as a result, there's more work in migrating to a newer version. There are significant architectural changes within this version. They're using OSGI for modularity. What this means to an end user is that we should be able to roll out changes more easily and not impact users. So it shouldn't require full restarts of the service to do many of the rollouts, which will be a good thing for our users. So that's LifeRay DXP. And then there was one other item on the agenda that I'm supposed to cover. I'm drawing a blank. Let me see.
Let's see.
Greg.
The Garrett case insensitivity has been.
Oh, that's right. Case insensitivity. This was something that it's bugged myself and many other people, and we've had to. It used to be that when you logged in to the web interface for Garrett, if you were typing in credentials, you had to use the exact same case. So whether that's, like in my case, Kenneth.Spiro with a capital K and capital S, or all lowercase, whatever you logged in the first time, you had to, moving forward, always log in with the same case. That also impacted users that were interacting with Garrett through SSH, where it required the same case there and consistencies. So that was a problem because oftentimes people mix the cases. Technically, according to the email standards, a mixed case and all lowercase are different, but the reality is that at NOAA's level, you're not going to have different accounts for that. So we put in place some logic that basically removed that case insensitivity, or it's now case insensitive. So the nice thing is that you shouldn't have issues now. You can log in with either case. You can also set up your keys and things like that, and your username with either case. What's happening behind the scenes is everything's switched to lowercase. So anyway, that's just something that should ease the use of VLab. And so if you have other issues or things where it's something where you're like, why did they do that? Or it would be really nice if it would behave this way. Let us know, because we'll see if we can, if it's a good idea or an idea that we have some flexibility to address, we'll do our best to do so. So that's it for me, I believe.
Okay, any questions for Ken before we move on? You can use the raise your hand feature in the GoToWebinar or send a question in the question panel. I'll give a couple seconds here. Okay, looks like we have a silly question. What is Garrett for? Asks Kelly Whitaker.
Yeah, no worries. So Garrett is it's an application that sits on top of the Git repositories. It's used for a couple different things. So if you have a project within VLab and you're using a plain Git repository, I'd highly recommend that you switch to using Garrett, because it provides a couple different things. One is that it's going to give you the ability to use SSH and keys, and so that streamlines the user experience, so you're not having to constantly type in your passwords. The other thing that it does is it adds the ability to control the underlying Git repository, so access controls. So you can actually set up rules that will allow you at a branch level to say, oh, well, people can create personal branches and they can work within those branches, and that's fine. They can push directly to it, like many projects do. But for the master branch, or any branch that you want to define, but oftentimes it's a master branch, we want to tightly control that. So in that case, we want to require that when someone goes to push something up to the master branch, they're going to do so through a review. So the Garrett interface, what it's mostly known for is providing a UI that allows code to be pushed up for review, and then the users can interact. So for example, here, this is my view. I think I'm still showing it. So I can go to my changes, and within here, these are changes I've pushed up. These are changes that need to be addressed. So I can click on a review, an incoming review, take a look at it, and then it's going to show me all the different files that were checked in. I can look at those files and determine, if there are problems. If I think that there's an issue, I can do, put in comments. That'll generate emails. The submitter, in this case, Jason Burks, would get notified of this comment. So I can say, this is a test. I'm probably giving you more information than you're hoping for, but maybe it will benefit you guys. So I can then go in and specify if I approve this, if I can give a general comment. And so basically, as the project owner / manager, you have oversight over what goes into select branches, and then that ensures the integrity of the underlying repository.
Okay, thank you very much, Ken. That was a good description. Any other questions for Ken before we move on? You can raise your hand or use the question panel. Okay, looks like no more questions for Ken. You can go ahead and take control back of the screen here. Okay, you should be able to see the agenda again. So next on the agenda, we're going to be chatting briefly with Tom Filiaggi. He's going to give some updates on what we're expecting to see in the VLab, a couple of nice new additions that he will demo in the next meeting in November, but he's going to give us a little summary of what they are. So Tom, you're unmuted right now, so go ahead.
Okay, thanks, Greg. As Greg mentioned, the tentative plan is to have me do a full demo of these added features on next month's call. But to mention it today, just to bring it up with you, I think is important because I think these two functions are going to provide some well-liked functions for those of you that are managing issues in the projects in Redmine on the development side of VLab. We're going to be deploying two new plugins, and the checklist plugin has been deployed, and I added a news item, so you should have received an email with the announcement that says, hey, we can now have checklists, and it gave a little brief description about what checklists are. If you did not get that email, and you're wondering, hey, Tom, what are you talking about? You might want to go to either the VLab Redmine front page or the VLab Redmine wiki front page, and there will be notices on there that will tell you how to make sure that you're getting announcements, which is usually a pretty good idea. We don't bombard you with stuff. We might send out one announcement maybe a month on average. So usually things that are important for the user base in Redmine to know. So there it is that Greg is showing you right there, how to receive announcements. Just real quick. So if you didn't receive that email about checklists, you might want to go here and sign up for announcements. Now back to those two plugins, the checklist is one that's just going to show, allow you to use, and big surprise, checklists in your issues. They're just things that you can check the box on or off to say that you've done these things or not for whatever issue you're tracking. But the Agile plugin is one that has a significant amount of function, and the reason why I'm not demoing it now is that we're right now in the middle of defining what a good approach is for this. So if somebody's not familiar with the Agile style of software or product development, but they've heard about it, maybe they've heard some good things and they want to try it out, we want to make sure that we give you good guidance to start with so you can start using the VLab Agile approach, but know that there are many ways to do Agile development. And if you talk to people who have used Agile, they can probably tell you all kinds of different stories. One person will tell you one thing, one person will tell you another. But again, we want to be able to provide you guidance that can get you started in a good place. Once you get familiar with what Agile can do and what it means to do it in an Agile way, then you might want to tweak and tailor your process to what you really want to do if you want to go in that detailed a direction. So again, I will be tentatively planning to do a demo on next month's call regarding the Agile plugin, and I'll show the checklist as well. But it might take, maybe a half an hour's time on the call, and we can talk about more details then. And if you know other people who might be interested in this, you might want to let them know about this call as well. Some of the things that are included by Agile plugin, we now are going to have some charts that will reflect the status of a number of issues. You'll be able to do a little bit of color coding. You're going to have a new way to view your issues. So instead of having an issue tab with a bunch of issues listed in a tabular-like fashion or with rows, you're going to have what's called an Agile board, and it has cards, and you can click and drag your cards between your issue statuses and things like that. So it's pretty interesting. One of the big differences is that depending on which trackers you're using to track your issues, some of the trackers can be fairly involved. They can be pretty comprehensive. That's not a bad thing. It's just a different style of how you want to manage your issues. But with an Agile plugin, because you're using a graphical board, usually the tracker is going to be a little more simple, less restrictive, to make it easier to move things around on your board. But again, it will be up to each project to decide exactly what they want to do and how they want to manage things. And once we get this demo out next month, hopefully you guys will be able to provide some questions for us, and we'll be able to answer those for you. So that's basically an introduction to what I'm going to talk about or demonstrate next month on next month's call.
All right, thanks a lot, Tom. Any quick questions for Tom? And we'll see more of this in 2 months. It'll be rolled out before then, but at least get the demo afterwards. So doesn't look like there's going to
Greg,
be. Go ahead.
You said 2 months is our next call 2 months from now? I didn't realize.
Yeah, November 29th.
Okay, so everybody ignore what I said about next month.
Well, you're going to roll it out next month, correct?
It'll be rolled out. It'll be rolled out before then.
Yeah.
As far as me giving a demonstration, it would be on this call whenever the next call is.
Okay. Yeah, November 29th will be the next one. So, all right. Well, thanks a lot, Tom. Appreciate it. It's like I've been muted. Okay, I'm back. Sorry, I was muted. We all do that once in a while. So the next item on our agenda, thanks a lot, Tom, by the way, is going to be our community project spotlight. And it's our presenter is going to be Rick Mathot. Am I pronouncing your name correctly, Rick?
You got it just right, Greg.
Okay, good. And he's going to be talking about the stock synthesis project and community on the VLab. And this is going to be our first product spotlight that I'm aware of that is going to be looking at the ocean side of NOAA. So it's a very active project on the ocean side, and Rick's going to give a little bit of a background on what the stock synthesis project is, and then he will also talk about how they are using the VLab to their advantage. So I'm going to go ahead and switch presenter to you, Rick, and you should be getting a notification. And there we go. Thanks. So take it away, Rick.
Okay. Well, thank you, Greg, for setting it up, and it's glad to hear the info on what's coming up in VLab. So, as he says, I'm a bit of a fish out of water here. So there are indeed flying fish. They can get up out of the waves and glide for tens of meters in the air. But the most recent incarnation of flying fish, of course, is Sharknado, which I won't talk about any further. I will talk about the range of issues that we bring to the table as we try to provide science advice for management of fisheries. So, because this, I'm sure, is going to be, fairly new for a bunch of you, I'm starting from a fairly general level. I'm going to go through what our legislative mandate is for assessments, what data requirements look like, what our models basically look like, how we use it to set up control rules for what the catch can be for fisheries. Then I'll talk specifically about the stock synthesis fishery model, which I'll say SS from here on out. I'll give a brief example of an application of it, and then I'll wrap up with the ways in which we are using VLab today in order to help us implement this project. So our mandate comes from the Magnuson-Stevens Fishery Conservation and Management Act, which was first enacted in '76 and has been reauthorized a few times since then. And National Standard 1, basically lays out what we're trying to do. We're looking to enable fishing, but we're also looking to prevent overfishing. So prevent overfishing while achieving on a continuing basis the optimum yield from each fishery for the United States fishing industry. And this includes both recreational and commercial interests in doing this. And it calls for some fairly specific deliverables. A mechanism for specifying annual catch limits such that overfishing doesn't occur, and measures to ensure accountability, and try to make it as objective as we can. And, really linking it to scientific information on the productivity of the fish stocks and how much catch they can sustain. So we're the source of that information. We aren't on the management side of it in the science we do, but the limits that get set, they probably have at least 90% of their information content coming from the science advice that we're providing. So it's fairly prescriptive advice that we provide. So, this sets up, this mandate for stock assessments. And I'll get to what I mean by those words, parse those words out for us. But, it's really about the balance between, on the left-hand side, of protecting the ecosystem and preventing overfishing, and on the right-hand side, providing food production, providing recreational opportunities, trying to get the balance of these right. The legislative history and the legal history, certainly has moved us into a situation where we err on the side of uncertainty. So, the thumb goes on the left-hand side here, where there's more uncertainty. We want to be certain that we're providing advice that will preserve future options. But right now, it's all about being able to come up with these annual catch limits so that we are indeed preventing overfishing while still allowing fishing to occur. So, I've used the word stock. What do I mean by stock? It's basically all the fish that are in a population. Now, we're going to have a demographic model, basically a life history kind of model of that population, but it's going to be treated as an entity. We do not have highly spatially explicit models. We aren't taking our data, interpolating it to a grid, and then running the dynamic equations that we have on that grid structure. We just don't have that information, nor are fish and the vagaries that cause them to move around known well enough in order to implement that kind of model routinely. So we treat, our models are conditioned around treating things as a unit. Now, we build some spatial structure in, but by and large, we're looking at the population of fish, the stock of fish as a unit. So our assessment process takes three categories of information. The upper left, you see catch, what's being removed from the population. In the middle, there's abundance, basically an indicator of how many fish are out there. And biology, which is giving us information on some of the rate processes that are going on. A lot of these rate processes, we don't have them as closely linked to the physical principles that you have controlling weather and currents in the ocean. But nevertheless, there are equations, there are principles about births and deaths of animals that we embed in our modeling, and we work to develop calibration of those processes through this model. So we have three categories of information feeding into these demographic population models, and with the goal of calculating, basically hindcasting, a time series of how abundant the fish stock has been over time, and what has been the rate of fishing mortality, basically how much extra mortality is the population experiencing because of fishing activities. And from this population model, we're then able to derive information like status. Status means, is the current abundance of the population so low that we call the population overfished, or is the rate of catch of the current fishery so high that we're saying that the population is experiencing overfishing? So overfishing is, catching too many fish, and overfished is too much of a decline because of past fishing. But we're also trying to be proactive about this, and that's the forecast side. And forecast is basically projecting forward the population according to some rate and using that to set the scientific advice on what the annual catch limit can be. So we need catch data in order to run these models. Commercial landings, recreational landings, the amount that's being discarded. We really need to get a good handle on total catch. It's pretty straightforward for commercial fisheries that land and sell their fish at specific places. It's very, very difficult to measure the total amount of recreational catch. Around Florida, where there's millions of recreational fishermen putting to sea in all kinds of ways and boats, it is very difficult to get a handle on the total of the recreational landings. Another component of the information that we need is the stock assessment surveys of fish abundance. And so here we're looking to go to sea ourselves to collect direct information on the fish populations. And so we have a statistical design to sample over the range of the stock and we use very standardized methods to do this. Some of the methods look a lot like fishing, and others use more of an advanced technology approach to doing this. So let me give you a couple of examples there. So here in the Bering Sea, we've been doing this survey for decades now. And so in the upper left, we see a map of the Bering Sea, and each dot or X is a station where we have collected a sample. And in this case, I'm showing the results in 1 year of the survey for a yellowfin sole, a flatfish that lives in the Bering Sea. And the bigger dots are closer to shore. That's typically where the yellowfin sole are. But it's a very multi-species survey. So we simultaneously collect data on many different species over these hundreds of sampling locations. And we have similar sorts of surveys that go on in most other areas of the country. But the habitat is difficult to do this kind of survey in many areas also. So, you know, we have this spatially explicit information, and we certainly are developing models that are using it at this kind of a spatial scale, this kind of, you know, many kilometers kind of scale of the population distributions. But, you know, for our purposes here today and for the stock assessments today, you know, this information about the distribution of animals across space is basically condensed down to what's an estimate that is proportional to the total abundance. And that's what we see in the upper right-hand side, a time series with error bars on the total abundance estimated from this survey over time. Another example, this is one using advanced technologies. Here we're using a towed camera system. This is off the northeast of the US. It's targeted on scallops. And in this blue circle, you can see it, you know, what 3 scallops are in that blue circle there. So it's a very quantitative approach, very highly standardized approach. We can get a direct estimate of how many scallop are off the northeast from this survey. They take something like 6 million images like this, and we have automatic recognition software that's helping us directly and quickly estimate the abundance of scallops. We don't get biological samples by doing this with a camera, and so we need to supplement to do that. And we are certainly developing these optical survey and acoustic-based surveys for other kinds of fish organisms in other areas of the country as well. But this one for scallop is, and scallop is certainly one of our most valuable fisheries in the US. It's one that certainly warrants this kind of investment in data collection. The third category of basic information is fish biology. And basically, as fish get older, on the x-axis age, they get bigger. And in the ear bones of the fish, the otolith, they deposit an annual mark. And from this, the kind of structure, we can collect data. So we have to get a sample of fish, extract the otolith from a sample of the fish, bring those otoliths back to the laboratory, do the sectioning of the otolith, and collect the information. So it's symptomatic of the fact that the pace of data collection that we have is really slow compared to what you're experiencing in weather. We basically typically operate on an annual or no more than quarterly time steps. The pace of fish populations sort of follows an annual weather cycle, and so we tend to look at things on that kind of an annual cycle. And so, our advice also comes out on like that annual cycle. So, thinking now more about the modeling aspects of things, the direct fishing effects on the numbers of fish at a given age in the population. So if you're not fishing at all, well, there's still some natural mortality going on. And so as they get older and older, there's fewer and fewer of them. That's shown in the green histogram. But once you add on fishing, by the time you get to an age where the fish are big enough to be caught by the fishery, well, now they're going to be diminishing at a faster rate because of that. And so this is really direct information on the effect of fishing on the fish population. So if we're fishing harder, if we have a higher fishing intensity, they're going to be diminishing at a faster rate as they get older. And so, an example of that is shown here, where here age is on the x-axis and time or year is on the y-axis, and the size of the bubble is what we've measured as the proportion of, or the total amount of catch of that age in that year. And in the early years, back in the 80s and early 90s, hardly any fish were surviving the older ages because there's so much catch at ages 1 and 2 and even at age 0. And then regulations were put in place to slow down the rate of fishing and also to prevent the catch of the younger animals. And so by the 2010s or so, now we have much more survival to some of the older age groups. So it's an example of the kinds of data that we're working with here. So, getting to, what's driving the dynamics here? Well, let's step way back, not even fisheries now. Let's just think about anything that's alive out there and what's the impact of adding mortality to it. So let's take our lawns. And if we don't mow at all, we're over on the right-hand side, and we got a nice, wide open place that's, fun for anybody to run around out in the field. On the left-hand side, if we are setting our mower really low and mowing really frequently, well, we have hardly any grass left. We're also not getting very many grass clippings out of it because there's hardly anything to mow. Whereas in the middle, we set our mower height a little higher so we don't get the smallest blades, and we're mowing about once a week. We're probably getting about the maximum grass clippings per week that you could get by having this intermediate level of added mortality being imposed to our grassy area. So, translating that to fish, if we aren't fishing at all, we're over on the right-hand side. So the fraction caught per year is 0. And now we get, some big fish and middle-sized fish and some small fish. Whereas if we fish really hard, now fish aren't going to be surviving the older ages. Will be over the left-hand side. And in the middle, there's a level of fishing impact that's going to give us the maximum long-term average yield from the population. So this is sort of the conceptual basis around which, having sustainable fisheries is built. And so, just looking at this in a little bit more detail, I'm not going to spend time on this when I move along, but, basically, if we have indications that the catch is greater than the amount of production, well, it's going to be, that's the big red arrow. That means we're going to be driving the population down. Whereas if we're catching an amount that is less than what's being produced by the population, then it's going to allow the population to grow. And again, we're trying to understand and calibrate these factors so that we can provide advice on what is a sustainable level of production and what catch next year would implement that level of impact on the population. So we take that kind of a concept and translate it into a very explicit regulatory language. And we'll have something that we'll call the overfishing limit, which is basically more than that, and you're going to get a nasty gram from high up that you're allowing too much fishing to happen. There's an acceptable biological catch, an annual catch limit, and potentially an annual catch target. So we're cascading down to additional considerations that are all moving us more in the direction of precaution where we don't quite have full technical control. So what this means is that where we can allow the annual catch target to be as close as possible to the overfishing limit is going to happen in cases where we have a lot of information, we really understand how the population is operating, and we can basically have a fine-tuned machine and dance right up to the edge to get its maximum production, but not too much production. Now I'm going to skip over this one. So, as we, think about categorizing how well we're doing in this, we can think about, this kind of a categorization of all of our stocks. So on the x-axis, it says abundance / target. So basically, if we're right at the 1, the population is about where we want it to be. And in terms of fishing mortality rate relative to the limit on the y-axis, a value of 1 here means that we're right at the limit. And so, we're in the limit is what gives us the maximum theoretical production. So it's a dangerous limit to be dancing up to that edge. And so, some categories that you see here. For in the lower right, the stock is abundant and we're not overfishing, whereas we're in the upper left, in the red, we're both overfishing and the stock is considered overfished. And when we start getting into the red, then there are the accountability measures I mentioned in one of the first slides requires that a rebuilding plan, this blue rebuilding label here, is to get stocks back in the direction we want to be. So, when precaution, then leads us into trying to be a little bit below the fishing mortality limit and a little bit above the abundance target. So this green target ellipse is really where we want to basically be able to be. And so, taking information, this is now several years old. We're actually doing better than this now. And yes, we have some in the red and some were way up in the red. And this is really keeps diminishing over time. We have an annual report to Congress on how much overfishing is happening. And we're really proud that we've been able to increasingly reduce this number up in the red. And we have plenty in the green as well. And a fair cluster in this area that would have been the target identified from the previous slide. So by and large, for U.S. stocks, we're doing pretty well. And it says here 140 U.S. stocks. Actually, we have near 500 separate fish stocks that we try to provide advice on. And the 140 here basically means that the degree of quantitative advice we have is not uniform across all of our stocks, but we're doing well for our major fish stocks. The picture is not so good. I mean, you certainly see plenty in the popular media about the status of global fisheries, and there certainly are areas of the world where the picture does not look nearly as good as this one does here. So, and let me switch now to the model that I developed, and is one of the models that we use in order to provide this kind of quantitative advice. So the term I've used for this, and it's been in existence now for throughout my career, really. And so it's stock synthesis, and I'll just call it SS. So the goal of this kind of modeling is to assimilate data to a state-space model, to estimate historical time series abundance and fishing mortality rate, to estimate sustainable fishing mortality rates, and determine if the stock is overfished or is experiencing overfishing relative to these sustainable rates, and then to project the population forward with the catch in order to provide a basis for setting next year's catch quotas. The model itself, we've got 26,421 lines today of C++ code. That's sitting in the development side of VLab. It's compiled with libraries for automatic differentiation, and you can see a reference down in the middle of the page here for what this package looks like to do it. We work in a PC environment. We aren't operating in a server environment. We have a lot of working group meetings or people sitting around with their laptops and doing various sensitivity analyses, trying to understand how well the models are performing. And so we work in this very hands-on PC environment. Stock synthesis is the most widely used of our models today, but we have similar regionally supported models that are similar in concept, but different in the exact implementation. So this issue of model diversity, model redundancy is something that we are beginning to think more about in fisheries today. Again, a little bit more about the model structure. There's a population model, which is basically about how the population works, what its rate processes are, how the fishing fleets interact with this population. There's an observation model where we derive expected values for the kinds of data that we have. a likelihood-based statistical model to quantify the goodness of fit, and then this this algorithm that's built within the auto differentiation model builder package to search for the parameters. So we're able to configure models that will estimate a few hundred parameters in minutes of time in the type of environment we do. We also do some work with Markov chain Monte Carlo searches, and those are more extensive investigations of the uncertainty of our models with respect to the setups that we're using. The models, is designed to cast its results in terms of the direct management quantities, and so any uncertainty that we have in the model parameters can now be propagated through the chain rule onto a confidence interval for those management quantities, and then provide advice that is associated with the uncertainty in that advice. A bunch of associated tools. I took this from a slide for another audience, really, but just pointing out that we have a graphical interface, this GUI, and it's basically a situation where we have a text-based inputs into the executable, and we have some pretty powerful tools for visualizing the model outputs at the end. We have a graphical user interface that has been recently developed for the model, and this helps us guide the users through good configurations of their particular applications. This is now a map that's a few years old, and it keeps growing, but we are global in our applications, and we have held workshops in Europe and South America, and we've really had a good degree of success in getting the global community to be moving in this direction. It's also very useful as a training tool. It gets used a lot in some universities to help new students get introduced to these concepts of population modeling. So it's been widely used. So let me move to a quick example. This is Pacific hake or whiting off the U.S. and Western Canada coast. And in the upper left here, we have the time series of catch by the various fleets that have been involved. So there's U.S. catch by factory trawlers, U.S. catch by shore bays, catch in Canada, different components. And we keep the components separate because each type of fishery, each type of fishing gear can interact with the population in a different way. And we work to keep that separate. In the upper right, there's a time series of a survey result that shows a high degree of fluctuation over time. And indeed, this is a highly fluctuating stock. And this survey is a good survey, but we need to do it pretty frequently in order to keep track of the trends. Because down in the lower left corner, where we have another of these bubble plots, this time it's year on the x-axis and age on the y-axis. And you can see these diagonal patterns of the bubbles. This is an indication that in some years, a whole lot of young fish came into the population. And over time, they got a year older, and they've supported the fishery over time quite substantially. So this boomer bust pattern is very dramatic for this particular species. So you see this pattern, and you see the quality of the data that we have about this boomer bust pattern of how many young fish come into the population each year. So from these data, the model results look like this slide, showing on the bottom an estimate of the total population abundance with confidence interval changing over time. And at the top, you see the estimates of the numbers of young fish or recruits coming into the population each year. And you can see how punctuated it is, that there's a few years with a tremendously higher level of recruitment than others. It's like 100-fold variation in the number of recruits. So close tracking and knowing, having data that tells us how many young fish are coming into the population is critical for setting a good forecast for what's going to be the population abundance in the coming year. So, think about this pattern we see at the bottom and the confidence intervals and where the population is heading. And now we'll move into the forecast or projection mode here. And so we have the estimate out through 2017. And here the modelers were showing, what is the expected population abundance over the next couple of years according to different levels of potential quotas that would be set over time. And so this is a population that's in pretty healthy shape, and it is projected to maintain this at basically status quo levels of catch. So the VLab, we have both a community implementation as well as a Redmine development implementation. Here on the community side, we have something like 229 users with a substantial number of them from around the world. This is just our opening splash screen. We use the forum a good bit for Q&As and to put messages out to the whole community. I'm just starting to use the wiki to a greater degree in order to basically write some essays on how to use this better. Within the document library, we have links to and availability to download a variety of products, including the latest version of the code. We just did a major development push, and we're now finished with that. And so the pace is going to start slowing down, but it's been pretty hot and heavy recently. And so just trying to provide a good welcoming message here as with easy guides to various places within the VLab system. On the developer side, I'm the major developer for the code itself, but someone else is doing the graphical interface, and a third person is doing the user manual in LaTeX. We use in the developer side extensive use of the issues to track and guide the development. So I'm looking forward to some of the things that I was hearing earlier in this meeting today about how that's going to be augmented. So in summary, our assessments are designed to answer management questions. Catch, surveys, and biology are key inputs. A variety of advanced technical methods are tuned to the diverse data availability scenarios. So both in terms of the data collection side, because different kinds of fish on different habitats need different collection methods in order to get quantitative data about them. And that affects how we can model it as well. And these assessment models then produce estimates of stock abundance, mortality, and productivity, and the forecasts provide the basis for guiding the level of annual catch limits. We'd like to think of it as an operational modeling system. It just operates a whole lot slower than a weather model system. But nevertheless, I mean, we are providing advice for something like 200 fish stocks each year as we use this kind of a system. And we have our developer side and our community side in order to make this happen in VLab today. So let me stop there and see if there's any questions.
All right, thanks a lot, Rick. That was very informative. Learned a lot about what's going on in that part of NOAA. We've got a hand raised already, so Steve Smith, go ahead, you're unmuted. Steve, you are unmuted. Go ahead.
Sorry, I had a double mute on. Thanks, Greg, and thanks, Rick. I really appreciate you taking the time to give us the full context of this and sharing, exposing us weather folks to this side of NOAA. Really cool stuff. So a couple questions on things on the VLab uses. I saw one of your slides that it would mention of GitHub. So were you using GitHub? Are you still using GitHub in addition to VLab, or what's the history on that?
Yeah. It's been a tortuous trying to figure out just what the NOAA policy is on GitHub, and frankly, our science community is very strongly connected to the academic community that is all over GitHub. And so it's been sort of inevitable that many of our scientists, have been working directly in the the public GitHub. And my push to put stock synthesis here into VLab was to try to move our community in this direction of having a more organized approach to how we share our information. But yeah, I did not have this in a public GitHub, but we did have a corporate GitHub account within our Northwest Center and I moved it from there into VLab.
Okay, thanks. So we're still waiting for the memo to be signed on use of GitHub, and I got to check on where that stands. It seems like it's been forever pending, but at some point we assume that it'll be officially blessed, and we can work with you to potentially do sync ups between your VLab repos and any potential GitHub repos, if that works for you. If that helps out your business model, at that time. So that's great. The other question, I guess, on the VLab side is that I think your community is the highest percentage of external users, lots of foreign users that we have. So is that working to your satisfaction? Or do you feel like these external users from foreign countries are benefiting from this approach through the VLab?
Yeah, I mean, it's actually a topic that I'd like to pursue with you, because I want to be certain that I'm not moving VLab out of a comfort zone in that percentage. We needed a way to disseminate updates of the code to the community, and we didn't have an easy way to have just a totally open website from which
Right.
we were going to do that, yet still be able to make it easy to upload. So we wanted to have a system like what VLab provides, but we recognize that the user community is widespread. Now, we don't have a high degree of communication with individual users. Like every project, I'm sure there's a few people who do most of the communicating through a system like this, and it's worked with them. But mostly we needed a way to be able to disseminate, and I'm totally comfortable having it being disseminated through a password-controlled system and not just a totally public download system. But if there's a way to mix and match so that we have some parts of it that are easy to just publicly download and not be part of the system, I'm willing to explore that as well.
Sure. We can talk more offline about that. We don't have any concerns. It's working for you. It's working for us. But we can maybe look at other options if they're more workable. I guess my last question's on some of the when you showed your map of the globe and the different stocks. So the idea here in your model is, you're focused by Magnus Stevenson on the quote unquote U.S. fish stocks, but you are hoping that to enable other nations, and I don't know how this works, who calls the Russian fish stocks versus the Chinese fish stocks and all of that, but it looks like you're trying to enable these different countries to use your model to do the sort of same thing to better manage their international foreign fish stocks. Is that the idea?
That is, but it's a mutual benefit. We are very hands-on with basically the open ocean fish, the tunas and the billfish that swim all over the place. And so, there's international forums that the nations get together. And so really the first stage of the negotiation between the countries on who gets to catch what really sort of starts with that science stage. So, having good tools we bring to that stage is important. And so, stock synthesis is used for a lot of those tunas now. And we also have bilateral agreements or multilateral agreements, in particular with Europe, with the ICES community. They have similar needs, and good degree of model development goes on there. And so, I've been to Europe. I've done workshops there, and the European scientists are an important source of external reviewers for our work. Our work, as I said, operates at a slower pace, and it's directly impacting the users, and so there's a high scrutiny on our outputs, and so having a external peer review system to look over what we're doing is important to get the trust of the affected community. And so the European scientists are play that role as well as we do for them. So it's pretty well connected, and they have similar needs.
Okay, great. Last quick question you had there were sharks showing up there. So I presume it's trickier for doing this with non-fished stocks like sharks, I presume, or maybe there are sharks are fished in some places in the world, but that one caught my eye. Yeah.
I mean, it's I've made stock synthesis flexible enough so that we have applications that run on a monthly time step for shrimp that live 18 months in the Gulf of Mexico. And, the same model with different rate constants works for surf clam off the Northeast. They live over 100 years. And there are sharks that are done. The hardest group to do right now with stock synthesis is really the crustaceans. Because they molt, like a lobster or a crab.
Right.
They grow incrementally by molting, and so it's a little different growth process, and that makes it a little harder. And they also are very difficult to measure the age of crustaceans. They don't have those otoliths that I referred to.
I see.
But by and large, the concepts are the same.
Got it.
And I've made stock synthesis flexible enough to apply to a wide range of them.
Great. Well, again, thanks so much for a very informative talk, and thanks for using the VLab to carry out NOAA's mission and your science. So really great stuff. Thanks, Rick.
Thank you.
Okay. Any more questions for Rick? You can use your raise your hand feature or send it in the question panel. Give folks a few seconds. I think that's it. Rick, wonderful job. Thank you very much for your presentation. We were really looking forward to it. Finally got you on here. So some interesting stuff and very good use of the VLab, both sides of the VLab collaboration and development. So, all right, thanks a lot. I'm going to go ahead and take over control again.
Okay, well, thank you for the opportunity.
You bet, thanks. Okay, so last part of the owners meeting is a roundtable. So everybody gets a chance now to ask a question about anything pertaining to the VLab. So again, use your raise your hand feature or the questions panel. And we'll just watch and wait and see if somebody has a question. As we did before, give everyone a few seconds. If not, nope, we've got one. Steve, you're unmuted. Go ahead.
Yeah, and not a question, Greg, but I do want to put out to the audience again that we are, we look for people who are interested to sort of join our support team. So if you yourself or somebody in your work group or somebody in your organization who might be interested in working on this kind of stuff and has the some skill or background in this, whether it's ITOs and the Weather Service Forecast Office or anyone in a lab or something like that, let us know. We're always on the lookout for people with skills that they want to exercise, and we can try to bring in to help us out, part-time or full-time or whatever it is basis. So I just put that out there to let us know if that's the case.
Okay, thanks, Steve. Well, seeing that there are no other questions, we'll go ahead and end the call, just want to let everybody know that a couple things. One, the next meeting is on Wednesday, November 29th, the same time as usual, starting at 3 Eastern time, and do your conversion for your own time zones. And as usual, all of these meetings are recorded. They will eventually be posted to our owners' community on the VLab, as well as YouTube, and I will send out a link to that once we've got that converted. So I'd like to thank all our presenters for today, Steve, Ken, Tom, and Rick. Some great presentations that we're having here. And without further ado, we'll go ahead and end for the day, and we'll see you again in 2 months. Thank you very much, everyone.